Dear ISBS delegates, it is a great pleasure for me to present our study titled, The Use of Upper Limb Prosthesis Optimizes Long Jump Approach Kinematics, a case study of an elite T47 athlete. The increasing number of amputees participating in Paralympic sports events have increased interest in Paralympic sports performance. Nevertheless, limited scientific data is available on sport prostheses and prosthetic adaptations. Previous studies have biomechanically analyzed jumpers with transtibial and transfemoral amputation in elite-level competition. However, there is little information concerning upper arm amputee long jumpers. Upper arm amputees compete as T45, T46 and T47. According to the International Paralympic Committee, participants in Class T47 are athletes with a unilateral upper limb impairment, resulting in some loss of function at the shoulder, elbow and wrist. Paralympic T47 athletes during competition may choose whether or not to wear upper limb prostheses. However, wearing prostheses, and an increased forearm mass, has been suggested to improve long jump performance due to horizontal velocity increase. So far, limited information is available regarding the effect of wearing or not prostheses on the asymmetry of approach step parameters of upper limb amputees. The objective of our study was to investigate biomechanical differences in long jump approach run when performing with and without upper limb prosthesis. It was hypothesized that, during the approach run, the asymmetry of step characteristics and joint angular kinematics of sprinting technique would increase when not wearing the prosthesis. An elite 47 long jumper was examined in the present case study. The participant had a right upper limb congenital deficiency and wore transradial prosthesis in athletics competitions. Spatiotemporal data of the approach run were collected by 2 steady and 1 panning digital video cameras at a sampling rate of 300 frames per second. Here the setup is shown. The participant performed simulated run-throughs of the approach run during a training session in 2 conditions: wearing the prosthesis or without a prosthesis. 2 attempts in each condition were recorded. The videos were then digitized, and the analysis was performed on step parameters of step length, frequency and velocity. Here we also see the possible errors in the calculation of distance and frequency due to the panning technique used and the recording rate of the camera. 2 stationary cameras recorded the kinematic parameters of early and late approach run, body center of mass, horizontal and vertical velocity, along with shoulder range of motion, and the maximum hip, knee and ankle extension angular velocities were extracted with the 2D DLT analysis. The angular momentum of the whole body about the transverse axis was calculated using inverse dynamics analysis and segmental moments of inertia. Asymmetry analyses were also performed on an individual basis. Asymmetry was quantified for each variable using symmetry angle equations and taking into account the intralimb variability. Mann-Whitney U tests were performed between bilateral and contralateral leg values for each step characteristic, to determine whether the asymmetry for each variable was significant with respect to intralimb variability. As shown in Table 1, a systematic asymmetry was revealed for step frequency and step length in non-prosthesis condition, which was reduced when wearing prosthesis. In the entire approach, the step initiated by the contralateral to the deficient upper arm leg was 6.1% longer, had 4.6% lower frequency, and was on average 1.8% faster in non-prosthesis condition. When wearing a prosthesis, a smaller difference in step length between bilateral and contralateral leg, and a non-significant asymmetry, was observed. Step frequency values remained unchanged between the 2 conditions. Finally, average step velocity difference between bilateral and contralateral leg was reduced when wearing prosthesis to 0.5%. As shown in Table 2, when wearing the prosthesis the following occurred. Body's center of mass horizontal velocity was larger. Shoulder range of motion of the contralateral upper arm was lower. Ankle angular velocity was lower for both legs. As shown in figures 1 and 2, when wearing the prosthesis the following occurred. Angular momentum of the whole body was larger. Ipsilateral arm had a higher contribution to the angular momentum of the whole body. When the approach run was executed without prosthesis, a significant asymmetry, of similar magnitude to that reported in able-bodied athletes, was observed for step frequency and step length. However, when wearing the prosthesis the participant reduced step length and step velocity asymmetry. The reduced asymmetry when running with the prosthesis can be attributed to the increased moment of inertia around the shoulder. When the participant was not wearing the prosthesis, the reduced angular momentum generated by the upper limb was compensated with increased range of motion at the shoulder. The findings suggest that the use of prosthesis assisted to the cancellation of angular momentum due to the forward and backward arm swing. When wearing the transradial prosthesis, the participant seemed to optimize the total body angular momentum, that led to less asymmetrical approach run and thus to higher approach velocity, which may eventually improve long jump performance.